So where we can use, first one is for hydrogen peroxide, oxidation happen for a hydrogen peroxide, and reduction for manganate ion. So it is losing 2 electron and manganate ion gaining 5 electrons. So electron numbers are not same. To make these electron numbers same, we'll multiply first equation by 5 and second equation by 2. So when we work out, this is our final equation after addition. And what is the simplest ratio here for manganate ion to hydrogen peroxide? The simplest ratio is 2:5. And simplest ratio for manganate ion to iron 2 was 1:5. And ethane dioate. So ethane dioate, what will be the overall equation? First, the half equation, as you can see, 2 electrons and 5. So when we cross multiply, again the ratio will be 2:5. This is ethane dioate. Like, because C double bonded with O, and O, this is a structure C2, and O4 with the charge -2 because each oxygen -1. This is ethane dioate. Eth because 2 carbon, N because they have a single bond, dioate because 2 functional groups are there of ester, that's why it is dioate. But what happened? The reaction between the manganate ion and ethane dioate ion is very slow in the beginning. And what happened? So we have to heat it. We have to supply heat energy around 60 degree to speed up this reaction. But what is the reason why the reaction is slow in the beginning? Because you can clearly see here the negative ion is colliding with the neutral molecule. In the previous titration, manganate ion was colliding with iron 2. So opposite charges are there. Like charges repel, unlike charges attract. So they will attract. So the ions can collide. But why ethane dioate and manganate, their reaction is slow? Because you can see this is a negative ion, manganate is also a negative ion. Like charges repel, that's why we don't have successful collisions result in a formation of a product. That's why we have to supply heat energy. So with iron 2, ethane dioate, for both iron 2 and ethane dioate react, because like example, if we have iron 2 and ethane dioate, so what will be the ethane dioate here? When we write the equation for ethane dioate, it is like Fe, iron is attached. This is a C2O4 is a formula for dioate ion with a charge -2. And if iron 2 is there, Fe is there, which is iron 2 is there. So the formula of this compound will be FeC2O4. That is the formula of the compound. So if you want the equation, when manganate ion is reacting with iron 2 ion, the ratio is 1:5. When manganate ion is reacting with ethane OH ion, ethane dioate ion, the ratio is 2:5. But we need an overall equation. So how to have overall equation? The number of electrons in the one should be equal here, because this is one overall equation A and this one is another overall equation. Electrons are not there because these are the full equations, not the half equations. So if we add the two equations, when we add them, so this will be our final equation, and which shows that the overall ratio between the manganate ion to iron to ethane dioate will be 3:5. Is it clear? So basically what we will do, how we'll solve this type of question. First, we will have the concentration and we'll know what volume of potassium manganate is used. So we'll get the moles of potassium manganate or manganate. And from moles of manganate, we'll get the moles of iron to ethane diode using a ratio 3:5. And from iron to ethane diode, we will work out the ratio that how many iron will be there and how many ethane diode ion will be there. The ratio is 1:1, so same number will be there. But we directly take equation instead of separately find ions for each other. So another example, 1.41 grams of a sample of iron to ethane diode is there, hydrated, dissolved in excess of dilute sulfuric acid made up to 250 cm cube. So first what we did, we make a solution of 250 cm cube. But we are not titrating all of it, because otherwise what is the issue with titrating all the substances? We need greater amount of titer from the burette, so we may have to refill the burette. That will increase the inaccuracy. That's why we take a small quantity of a substance for which we are finding the concentration or the moles. So we make a solution, and reason for making a dilute solution, so that we need a small quantity of titer which we add from the burette. So it made up to 250 cm cube, but we only took out 20 from 250. We only took out 25 cm cube, and that 25 cm cube is titrated with the solution of potassium manganate 23.45 and more concentration 0.0189. What is the percentage by mass of FeC2O4.2H2 in original sample? Like in the original, because it is impure, we need how much is exactly there. So first, concentration into volume will get the moles of potassium manganate. Using the moles of potassium manganate, the ratio as we work out in the previous, it is 3:5. So we can work out the moles of iron to ethane diode. After getting a moles of iron to ethane diode, but that is the moles in 25 cm cube. To get into 250, it should be multiplied by 10. And then after getting the moles, multiply by molar mass, you will get the mass in gram. So if you need so only 1.33 grams was there, and remaining is impure. So mass of pure sample 1.33 divided by mass of impure into 100. So this is 94.1% pure by mass. Is it clear? Then iodine thiosulfate titration, that also did in AS. That's the same thing. In iodine thiosulfate titration, what we do, in a solution we have iodine and we add thiosulfate. So when the solution get paler or lighter, we add starch to give a sharp color change. If starch is not added, then the color change, because it will be difficult when the light color disappear. But when we add a starch, it will turn blue black, and when blue black color disappear, it will be easy to recognize. Starch is not added in the beginning of the titration, because if you add starch in the beginning, it will form complex with iodine. So we need a greater amount of thiosulfate to remove this iodine from this complex. Then how to work out the errors of the apparatus? Like example, if I say a balance is 0.001 gram accurate, that's a least count volumetric flask, pipette, burette. So sensitivity divided by measured value multiplied by 100. Example, if we use a 25 cm cube pipette, so or we use a burette. So calculating the maximum percentage apparatus error in the final result, add all the individual equipment errors. Like here example, if it was 0.05, it is done for 0.05, not for 0.1. So its smallest value or the sensitivity error is 0.05 divided by value recorded 25 into 100. Now to decrease the apparatus error, what we will do, if you want to decrease the apparatus error, de decrease the either decrease the sensitivity error by using apparatus with a greater resolution, or increase the size of the measurement, because the error, the percentage, if I, it depends on sensitivity. If I decrease the sensitivity, more accurate instrument, if I decrease sensitivity, percentage error will decrease. Or if I use or record greater value, then the percentage error will also reduce. So either measure a larger volume or use more accurate apparatus. Then if looking at a series of measurements in an investigation, the experiment with the smallest reading will have the higher experimental error. So when you have the values like it is written 20, 25, 30, so the one which is smallest value will have the highest percentage error. And if the burette is used in the titration, the uncertainty of each reading is 0.05. So the total uncertainty will be 0.1, because we have to read, when we are reading a burette, we are reading a scale twice and then calculating a difference in volume. That's why the uncertainty, even though this is written 0.05, but it will be twice, because we have to read the initial volume, we have to read the final volume, and then we have to take the difference in the volume. So this will create an uncertainty of 0.05 in the reading. This will also create an uncertainty. So total uncertainty will be 0.05 multiplied by 2, divided by value recorded, multiplied by 100. So reducing errors in titration, if you want to reduce errors in titration, replace the measuring cylinder with pipette or burette and reduce the error in a burette reading. It is necessary to make a titer large, or this could be done by increasing the volume or decreasing the concentration, like increasing the volume and concentration of substance in the conical flask. Like if I use greater concentration, but it should not be increased too much, otherwise we have to refill the burette. So if I increase the concentration or volume, means I will increase the moles, so I need greater amount from the burette. Or decrease the concentration of substance in the burette, so I need a larger volume for titration. And if you want to reduce error in measuring the mass, we will use more accurate balance and measure before and after to ensure for accurate reading. So example, calculate the percentage difference between the actual value and the calculated value. So example, if we calculated the relative molecular mass, which is 203, and the real value is 214. So how to calculate a percentage difference? Percentage difference is maximum minus minimum divided by the standard value into 100. If standard value is not given, then we will work out the mean average. So how to know whether the error in the experiment, like error in the value, is due to the apparatus or due to the experimental technique which we use. So if percentage error due to the apparatus is less than the percentage difference, like when we calculate the percentage difference, so if the percentage error for the apparatus, for all the apparatus will sum, that will be the total percentage error. So if the percentage error is less than the percentage difference between the actual and the calculated value, it means that the results or the error in the results or result is having a difference due to other errors. But if the percentage error due to the apparatus is more than the percentage difference, it means all errors are due to the equipment. So using this percentage error and percentage difference, you can work out whether the wrong result is due to apparatus or wrong result is due to other factors. Is it clear? These are the numbers. Like example, here I calculated the percentage difference, that is coming out 5.4, and the percentage error due to the apparatus is coming out 2%. So percentage error is less than the percentage difference. Percentage error of the apparatus less than the percentage difference. It means it may have, like, maybe during a reaction temperature changes, maybe the conditions are may not be feasible for reaction to occur. So there are many reasons. So other factors are there. If percentage error due to the apparatus is higher, it means that the error is all due to the apparatus which we are using. Some questions, MCQs related to the reduction of nitrate 5 ion by aluminum in alkaline condition may be represented by equation. From the change in oxidation number of nitrogen and aluminum, it can be deduced that the value of X and Y. What could be the answer for this? You can take your time to calculate. So here NO3 with a charge -1 change to NH3, and aluminum changes to AlOH4 with a charge -1. Now, what is the charge? Because for when I check the nitrogen here, what is the oxidation number of nitrogen? If it is NO3 and the whole is charged -1, so each oxygen is -2, so 3 oxygen will be -6. So nitrogen is +5 here. So nitrogen is +5. And here one hydrogen in NH3 each hydrogen plus 1, so 3 hydrogen plus 3, so nitrogen should be minus 3, because more electron, when two non-metals are there, the one which is more electronegative should have negative oxidation number. So basically it is converting into minus 3. How many electrons it should gain to convert from plus 5 to minus 3? So it should gain 8 electrons. Now what about aluminum? When we work out, because it's an element state, so oxidation number is 0. When we work out for AlOH, so when we work out for aluminum AlOH with the overall charge of -1, the 4 is with the bracket. Here also by mistake I wrote this is outside. So one oxygen is mine for this one. When we work out, what should be the charge for each? Because overall, so aluminum will be, yeah, oh, so each aluminum will be plus 3, because the overall each hydroxide ion you can work out, like hydroxide is -1, so there are 4 hydroxide ions, so this will be -4. So aluminum should be plus 3 to have the overall charge of -1. So aluminum 0 change to plus 3, 0 change to plus 3, it means it should lose 3 electrons. So it should lose 3 electrons, so this should be 3. Now, when we are writing a redox equation, the number of electron lost by one should be equal to number of electron gained by the other. So to have a balance equation, this first equation should be, so this first equation should be because 3 and 8 are not in the same table, so multiplied by 3, and the second equation should be multiplied by 8. So if it is multiplied by 3, which number will be there beside nitrate ion? 3. And which number will be there beside aluminum? 8. So the correct answer is D. Is it clear? Question 3. Which of the following is the correct for standard hydrogen electrode? For standard hydrogen electrode. So the temperature kept 273 Kelvin. No, it is 298 Kelvin, so it's wrong. Sulfuric acid has a concentration of 0.5 mole per dm cube is used. We do not use this sulfuric acid. Metal electrode is made up of copper foil, wrong. Hydrogen pressure 1 atm is there. So D is the right answer. Reason why cross D means it's a right answer. Next question. The standard electrode potential of the two electrode systems are given. What is the electrode potential of the cell? In which the chromium Yeah, that's right. B is the correct answer. So how you will work out, look, the one which is higher value, that is reduction, and oxidation will happen for the other. So reduction minus oxidation, redox. So it is minus 0.40 minus and minus 0.74. So that will be, when you solve, this will be minus 0.4 plus 0.74. That will come out 0.34 volts. And if I reverse the equation, like example, the same equation was given, but if I reverse the arrow, the direction of arrow, then it will be minus 0.34. Negative electrode, negative cell voltage means that it is not a spontaneous reaction. Non-spontaneous reaction will have electrode potential negative. Question 5. Calculated electrode this is a symbol for standard. The calculated standard electrode potential for reaction is positive, but the no reaction occur when reagents are mixed under standard condition. It can be deduced that what we can say about this statement. What could be the right answer for this? So A is the right answer, because what happened? They are thermodynamically feasible because the electrode potential is positive. Means for a cell, it means the reaction can happen, but it is not happening. It shows the conditions are not favoring for reaction to occur, or at that temperature the reaction does not start. Reaction is thermodynamically and the reaction mixture is kinetically unstable. If it's unstable, it should react. The reaction mixture is thermodynamically, that's wrong. And reaction mixtures, other statements are totally wrong. So A is the right answer. Then here we have electrode potential of a cell is directly proportional to entropy, and it is directly proportional to L and K. So higher electrode potential means greater entropy. That was January 2015. Okay. Next is, this one is January 2016. Uh, just a minute, I will share June 2015 as well. This one is June 2015. What is the oxidation number of oxygen in hydrogen peroxide? So for hydrogen peroxide, it's because the overall compound is neutral. So one hydrogen is +1, two hydrogen will be +2. So oxygen should be -2. Two oxygen are -2, so each oxygen will be -1. Question 2. What's the right answer for question 2? For question 2, is it clear? What's the right answer for question 2? Copper react with nitrate ion in acidic condition to form copper 2 ions and nitrogen 4 oxide. Nitrogen 4 oxide means nitrogen dioxide. So there's a nitrate. Best way just to write a simple equation. So nitrate, here is +4 and here one oxygen is -1. So when we write the overall charge, this will be +5. +5 change to +4. How the +5 will change to +4? By gaining electron. But copper is actually losing 2 electron and nitrate ion is gaining only 1 electron. If we need a balance equation, so number of electron lost by one should be equal to number of electron gained by the other. So if copper atom is changing into copper ion by losing electron, so nitrate should gain the equal number. So we'll multiply this nitrate by 2. So the ratio between them will be 1:2. Question 3. Electrode potential for a cell is 1 volt. What can be deduced about this reaction? So equal may, because high positive electrode potential means the reaction is feasible, so you will get product, mainly product, but if it is having a very high value, equal approximately, if 0 volt is there, then you will have, it's about about 0.6, means from 0.6 reactant more like negative 0.6 is there, it means the reactant more than a product. 0 approximately same, you can consider that reaction, no change in concentration. More than 0.6, it means the product more than reactant. Question 4. The cell shows the diagram below. Setup: titanium strip and silver strips are used, titanium 2 nitrate and silver 2 nitrate. The EMF at a standard condition is 2.43 of a cell. The electrode potential value for a silver is 0.8. What is the electrode potential for titanium? So how you'll work out, look, you have the formula: electrode potential of a cell is equals to reduction minus oxidation. So if you think A is the right answer, example, you think A is the right answer, so you will compare A with silver. So when you compare titanium with silver, because titanium is having a higher value, so for this reduction happen and the other one oxidation happen. So it will be 3.23 minus 0.8. What's the answer if 3.23 minus 0.8? Same way when you check the other options, When you work out the other option, the titanium ion is